Hello, everyone. Welcome to our webinar series. This is the first part of a Zeno tutorial. Quite a bit of material to share today. So we'll wait probably another minute and then we'll keep going because I see that we already have quite a few of you online. The menu for today will be Zeno, obviously. And again, we will go real quickly through some of the key concepts and then try to look at as much code as possible. That's the basic idea. Okay, so I'll be sharing my screen and I think we'll keep going. So I think my screen should be sharing. And I would say, let's go. Let me just hide this one. And we are good to go. Okay, so Zeno tutorial part 1. Let's start real quickly to just giving you some background of the problem that we are trying to solve or that we wanted to solve when we did Zeno, right? More and more application today actually span from the data center down to the microcontroller. If you take as an example, robotics application, automotive application, usually, on the device, so let it be a robot or a car, you already have quite a few, let's say, quote unquote, computers. Those could be microcontroller or board with regular processor. But in a car today, you have around 250 processor. In a complex, in a very simple robot, you have at least two, let's say, processor, one of which might be a microcontroller, the other might be a general purpose processor. On more complex robot, you have more of that. So you already see that we have a distributed system inside the device, but these devices are not standalone anymore. You need to have efficient communication inside the device, again, the robot, the car, whatever. But then all of a sudden, the scope is expanding. We need to be able to communicate, to store and compute in what is today called this continuum that goes from the data center down to the device. And with 5G in place, 6G coming up, and actually, if you look at the trend, forgetting for a moment 5G, 6G, and so on and so forth, but even if you look at the trend from cloud provider, I believe it is just a couple of days that Amazon has announced also that they're increasing their presence on the edge. So inevitably, right, you will have your system will get more distributed across this continuum, and you will be able to manage it. And the challenge are, how are you going to make all these things work seamlessly, right, without ending up with a picture like this? Because today, when you try to build this system, usually you have to use disparate technology and different technology to address the embedded world. So let's say the world of microcontroller versus what you use on the cloud, and so on and so forth. And this is true for when trying to move data around, but it's also true when you try to express distributed computation. And if you think about data storage, it's even more complicated because most of the storage, if not all of the storage technology today, are host-centric. When I store data in a database, I need to know where is the database in order to issue a query. And that location dependency or host centricity introduces quite a bit of complexity when trying to build these kind of systems. So this is really a cross-industry problem. You have it in robotics, you have it in automotive, and you have it in general in IoT and edge. And several years ago, we started working on Zeno to structurally address this problem. Why so? Because most of the protocols that people are using today have been around for at least 20 years, if not longer. And 20 years ago, the world was very different. 20 years ago, usually we were focusing for communication within a scope that was much more constrained with what we need to address today. And again, communication, so data movement and data at rest were addressed by completely different technology, as was distributed computations. So when we did Zeno, we tried to come up with a protocol, actually, to be fair, right, that was unifying the way in which you could deal with data in motion and data at rest. So data in motion typically is dealt with by means of PubSub. Data at rest means, databases being able to query. And we wanted to make sure that, while integrating these two worlds, we were able to retain location transparency. Location transparency is very important because it makes sure that I do not need to know where the data is stored. I express my query and somehow, the data gets to me. We'll illustrate that today. I think we'll probably cover some of the routing aspect in the next webinar. So Zeno support all of these. And as a side effect, as we will see in this webinar, and we'll play around with some code, actually the mechanism that we use to represent these oracles that are around the network that answer a query can be used to represent either the reading half of a storage, right, or something that is storing data. But in general, it's a generalized computation. Because you ask me, whether I have a data set and that data set might be computed, right? So it's just a generalization of the query, as we will see. Something that sometimes undergoes not very much noticed is that Zeno also support built-in zero-copy and share memory. This is without any external dependency, and there are some nice goodies coming up with the version 1.0 release. So something else that I will clarify in this webinar is the relationship between Zeno and Zenopico, okay? Because, I mean, Zeno really is the protocol, and then we have the Rust implementation of the Zeno protocol, which is also called Zeno, which sometimes I think creates a little bit of confusions. And then, as we will see, we have Zenopico, which is a C implementation of the Zeno protocol that targets microcontroller, but we'll get there in a moment. Before getting there, let's say that the bulk of our infrastructural node and one of the implementation of the Zeno protocol is 100% in Rust. This is the implementation that most of the people use, even when relying on C or C++ API bindings, as we will see today. More coming up. But again, besides bindings or language bindings for Rust, C++, Python, REST, Kotlin, and so on and so forth, built-in support for shared memory. Something else that is quite important is that at the protocol level, right, and that's independent of the programming language that we're using for implementing it, we can see it as low as a data link. There is a transport plugin mechanism that allows us to plug in your favorite transport as far as it is able to have a packet-oriented abstraction. Now, in the list that I have, in the second last bullet, you see serial. Serial is not packet-oriented. And so what we have in Zen is that at the transport level, we have this MAC abstraction that whenever there is a data link that is not packet-oriented, we make it packet-oriented. And as far as you have a best effort packet-oriented data link, Zeno can run. As Zeno does its own routing, as we will see, right, technically, you don't need IP. So the advantage is that you can use Zeno to very nicely mix IP and non-IP networks, okay, and build pretty, interesting systems. So we have support for mainstream operating system, obviously Linux, macOS, Windows, QNX coming up. Embedded target, Arduino ESP32 Embed and Zephyr being some example, but there is more. And we also have support in Zeno for AutoSAR Classic. As of today, we support Vector MicroSAR. Now, talking about infrastructural node and topology. So in this diagram, routers represent Zeno infrastructural element, which, by the way, are software router. Those are quite lightweight because you can easily run them on a Raspberry Pi 2. Peer and client represent Zeno application that use, let's say, certain feature of Zeno to allow for certain communication topology. Now, the key point is that you can build a Zeno network that is routed, so uses router to communicate, between, across the internet or between a subsystem, or even within a pretty, I would say, articulated multi-core deployment. Okay, you might want to separate different gangs of application because of communication affinity, and there are lots of interesting things you can do with router. There will be a few more coming up with version 1.0. But in general, think of a router as a way that allows you to communicate and to organize and to structure your system. And within subsystem, then application can communicate obviously peer-to-peer over a click. They can communicate peer-to-peer over a mesh topology, or they can operate as client. Operating as client essentially reduces the request, computational request on the application, right? That all of a sudden requires someone to mediate communication in order to reach out other application. And this entity that mediates the communication could be a peer, as shown in this diagram, could be a router. So this is interesting because all of a sudden, actually, you can build system in which you support mesh topology and in which some devices are extremely constrained, and they would pair up with the closest peer and use that peer to communicate with other peers and other clients. So that's quite powerful. So I'll give you an example, just to quote some other news that that maybe most of you heard recently. So it was announced an agreement between Starlink and John Deere on and so why is that interesting? Well, that is interesting because all of a sudden, through Starlink, you can kind of close the digital gap that there is today in remote agricultural area, where it's very hard, although you might have autonomous harvester and combiners, then to have any kind of backend connectivity. Think for a moment, those robots, because those are robots running Zeno, right? And all of a sudden having routers with Starlink connectivity, okay? I mean, you're in business because all of a sudden you could have, one or a couple of routers, especially, well, in fact, one router with Starlink connectivity, and the rest of your system would communicate through Zeno, right? And anything that needs to go to the data center or in any other place would leverage transparently the router to be pushed there. And that's nice because it reduces the cost of your system. All of a sudden, you just have an antenna deployed in a place where there is a router. You could even be more articulated because you could use router to create, and there are solutions to do this, either mix private 5G with satellite communication. So with this rich topological support, let's say that the only limit on how you build your system is your creativity. And again, if you think at the emergence of private 5G and the implication of having a router deployed with your access point, and then potentially having some router with satellite link, things gets very interesting. Okay, keep moving it. I want to put the topology in perspective. So if you compare Zeno to other famous protocol, DDS on one side and MQTT on the other side, you see that MQTT forces you into a client to broker paradigm. And this is the reason why when adopting MQTT, often you scratch your head and say, where am I going to deploy the broker? And often the broker ends up in the cloud, which is very far remoted. And that has implication on latency. It actually has implication on energy consumption when crossing and sending data for thousands of kilometers only to communicate with a device that is just by your side, right? On the other end, and is dramatically opposite, you have DDS, which actually support peer-to-peer under the assumption that every peer can communicate with every other peer. And then you have Zeno, which the promise is unconstrained connectivity, because a technology shouldn't force a topology on you, right? It should support and allow you to design the right topology for your system. And this is the philosophy that we have in Zeno. So as we talk about router, I would like to remind, and we will see some of this in action, we will see two plugins today, just to give you an heads up, the storage plugin and the REST plugin. Okay, so Zeno routers have a plugin mechanism that allow for us or for you to easily plug either third-party protocols. So we already have connector to DDS, to MQTT, a specialized connector for ROS2, a connector for ROS1, WebSocket connectors, but also to storage as backend. And we support InfluxDB, RocksDB, Amazon S3, Minio, main memory and file system. And then there is something else that we'll discuss in the third webinar of this month, which is ZenoFlow, something that we, the first major version is about to be released. That's a data flow computing framework, declarative data flow computing framework that leverages Zeno to give you the ability to really have data flow computing, again, in the cloud to microcontroller continuum. So let's quickly look at who is using Zeno today. And I decided to add these slides because even up to a couple of days ago on Discord, there were some user asking about, who is using Zeno, who has adopted Zeno, is Zeno deployed? So let's try to answer some of these questions also in this context. So if we look at robotics, Zeno has probably adopted the strongest adoption in robotics. and more importantly, because of all the problems that it has solved in robot-to-robot communication over wireless network. If you are coming from robotics, perhaps you've already experimented with it, or you have heard some of the success stories of the main user leveraging Zeno to address the challenges they were having on R2X. There were lots of super interesting presentations on our Zeno user meeting on the 12th of December, and you can find those on our YouTube channel. So it's YouTube and then at ZettaScale Tech. And again, as of today, not only there are quite a growing number of open source users of Zeno, but there are several industrial deployment of Zeno in robotics. So that's an important point. Then the other important news, which I think is not so much of a news anymore, because the first release of the RMW is about to come, should be released in May. But Zeno was selected as the RMW alternate for ROS2, okay? And again, we're working closely to Intrinsic, supporting their brilliant team to make this happen by the next release of ROS. And that came out of a throughout evaluation. As far as you search RMW alternate on your favorite search engine, you will find this document. Otherwise, the full report will be available as part of the slides. And as part of that report, it was very flattering for us to see how the majority of the ROS users were actually asking for Zenoh to be in. Let's look at what is happening in automotive. And I'd say automotive was the revelation of 2023 in a way, right? So first of all, tail of 2022, there was a very important recommendation from ITUT concerning communication between intelligent transport system that was identifying Zeno as the ideal protocol for that use case. Then there were recognition in 2022 for 2023 and 2023 for 2024 as Zeno being one of the key technology for V2X, and as such, ZettaScale being one of the startups to watch both in 2023 and 2024. Then the recognition from the Eclipse Software-Defined Vehicle Initiative that selected Zeno as one of the communication middleware, in addition to MQTT, right, with a different that Zeno is being leveraged in vehicle also. Then uProtocol, which is a super interesting project, started last year by GM, or a little bit over a year ago by GM, creating a universal platform for automotive that actually selected Zeno as their first transport implementation. And again, ZettaScale is actively contributing to this initiative. And you can easily follow it through Eclipse SDV or through the repository on GitHub that are available as part of these slides. And then obviously this is just a quotation from a user meeting presentation that was done by Stephen, which again, I suggest you, if you have not seen it yet, it's very insightful to see, what they, why they liked Zen and what are some of the reasons that motivated this kind of integration between uProtocol and Zeno. Okay, so, but that's not it, because I don't know how many of you are aware that today there are equivalent of SETI@Home. So those are super interesting distributed analytics platforms coupled with digital currencies that are used essentially for you to lend your hardware and be paid back with crypto. So essentially you allow other people to mine and do data analytics on your hardware, and you gain crypto by doing that. So there is such a platform that is entirely built on Zeno and has been deployed already for a couple of years. We have, at least as far as I know, 2 blockchains running on Zeno. And again, if you are part of Discord, you know probably exactly what I'm talking about, because that was announced. The second one that I'm aware of, we were informed probably 1 month and a half ago, and they were quite impressed by the performance that they were getting with Zeno. There are applications in industrial automation, and so the applicability of the protocol is rather universal. So I think it's good to know what other people and where this is being applied. And to this end, in last year, so in early last year, there was an interesting article from Amazon identifying Zeno perhaps as the protocol for, or the ideal protocol for IoT going forward. Okay, so that said, let's go back to the technical matters. And let's look at the Zeno programming model. So in Zeno, everything is a resource, where a resource is a couple between a key and a value, okay? So a value technically in Zeno is a payload with an optional encoding, okay? And we'll get there when we'll look at the implementation. And there are certain types that, as we will see, that Zeno understands natively. So essentially, Zeno understands natively primitive types, so integer, strings, float, booleans, and so on and so forth, and then gives you a way, if you want, right, to attach essentially MIME types to the value that you are producing in order to propagate this information, which can be relevant, as we will see on some of the example. Now, Zeno doesn't force on you a serialization format for your custom types. Why? Well, because in our experience, a serialization format change, right? You might already have system that are using protobuf and you want to reuse exactly the same information model without having to change. So we didn't take a stance. And as I will show, because this is again one of the common requests that we have, how do I use Zeno with protobuf? We'll see on this webinar, both in C++ and Rust. It's very straightforward, honestly. And as it is so straightforward, as I will show you, we really didn't want to constrain you with one format, right? But at the same time, it's pretty straightforward to pick your serialization, favorite serialization format for the user data that you're sending. But besides that, right, primitive types are already understood natively for Zeno, and the rest, you take care of serializing, but you have the ability, as we will see, of tagging with some MIME types. So again, a resource is a key and a value, and now you understand that the value, essentially for us, is a blob with some information about what the blob contains, where that additional information is optional, okay? Then we have key expression, and a key expression is an expression, sorry for the repetition, that represents or identify a set of keys, like home, kitchen, sensor, star, or home, star, star, temp, where the difference between star and star, star is that single star expands just to, well, cannot include forward slash, while a double star can also match forward slash, okay? That's the difference. And then you have selector, where a selector is nothing but the combination of a key expression, then the question mark, and a bunch of arguments, where these key arguments can be used to represent selectors, projectors, in fact, whatever you want, okay? Okay, so then we have publisher, subscriber, and queryable. And again, this is kind of correct, and I want to get to there. Strictly speaking, and in reality, on Zeno, there are only subscriber and queryable. On the network, on the wire, the concept of a publisher doesn't exist, okay? So you will see that in the API, we provide the concept of a publisher. So what does it really mean? Well, a publisher is just a way of optimizing recurring, let's say, put, as we will see, as they're called in Zeno, over a given key, okay? Why? Well, because we do some eager registration of resources. As I believe I've explained in other webinar, in Zeno, although we use string to identify resources, these strings are mapped to a very small integer, but they are mapped using heuristics, unless you explicitly register a resource or unless you declare a publisher. So really, a publisher is just a way of giving us a hint that you are going to write very often, with that key expression. But as an endpoint, it doesn't exist. So with that context in mind, I think it's still useful conceptually to believe or to think that a publisher exists, right, as an entity on the network, but in reality, it doesn't, okay? But so a publisher is nothing but a source for value of a given key expression. Then you have subscriber that are sinks for value of a given key expression, and queryable, which really are a place like a well where you go to look value or resources that match a given key expression. In terms of primitive, you have open close to deal with session opening. There are quite a few things that are negotiated during an opening a session. We figure out if we can do share memory. Authentication is done. If the authentication plugin, you have an option to negotiate sequence number resolution, and so on and so forth. Then you have bunch of declare. So declaring a key expression, again, that's an optimization. You don't need to declare a key expression in order to properly operate on key expressions. You declare subscriber. Well, that is required if you really want to subscribe, right? And you can pass a callback, or in some API, you get back a stream. You can declare a publisher. Again, as I explained, that's an optimization. And you can declare a queryable. That's a real, network endpoint. We need to know where there are queryable, because that information is used to route query. Okay, so if you want to have a kind of short explanation of why we only need subscriber and queryable as network endpoint or protocol endpoint, is because those are the things to which we either route data in the case of subscriber, or we route queries. That's the case of queryable. And then for those of you that are curious to figure out how data is routed back from queryable to the querier, so the one that issued the query, well, that uses a technique called breadcrumbs that was invented on the context of network, named networking protocol. Okay, so in terms of primitives, then we have put to associate, or to put the value of a resource, delete to delete a resource, pull to pull data from a subscriber, get to issue a distributed query. Now, something interesting about Zeno is that if you look at the primitive that we provide, actually, our abstraction are universal with respect to what you would need in order to express the key patterns in distributed computing. So let's try to understand. In distributed computing, usually you want to be able to distribute information, right? You want to be able to trigger computations, and you want to be able to store and retrieve stored data in the distributed system. And so distributing information usually is done using a paradigm that follows the publish subscribe, and that's trivially supported in Zeno. Remote computations, and in fact, a generalization of RPC is represented by our queryable, okay? Because if you think about traditional RPC like gRPC or Java RMI and so on and so forth, you have a client and a server. A server exposes a given set of services, perhaps accepts the interface, and I invoke a request on that server. In the case of Zeno, you issue a query. A query identifies the dataset you're interested in, and then you actually don't know who is answering that query or how many entities are cooperating to answer that query. So that is very flexible and lends very easily to do load balancing, parallelization, fault tolerance, and so on and so forth. And then storages, right, can be represented just by a combination of a queryable and a subscriber, where the subscriber is used as the element that allow us to inject data in the storage, and the queryable allow us to pull data out. So let's try to see how this works in action with a little animation. So whenever there is a publication, obviously Zeno will route this information to all active subscriber and all, well, in this case, Zeno storage, because you understand that a Zeno storage is a couple, is represented on the wire by a subscriber and a queryable. So all storages whose key expression matches the resource that was published. Likewise, here we have another publication. In this case, there is a subscriber that happens to be a full subscriber. So Zeno promises you that this data will be stored on the closest router, so that then the subscriber will be able to pull it at its own pace when it wakes up or it has connectivity. So this feature is very useful for devices that go under a duty cycle. And then we have the distributed query. So here I can issue a query, perhaps on this side of the network, I'm looking for something on all the car belonging to fleet 1. So in this case, perhaps the best way of addressing this query is to query directly the storages that are on the car. And so Zeno will route the query and then consolidate back the result. But if I move around, or somebody else on the other side of the world issues the same query, maybe the data, it's already available in a data center and that's closer to me, and I might get it from there. So that's another interesting aspect of Zeno, that for how the protocol works, it naturally supports load balancing and mobility. So I'll give you an idea. Suppose that all of a sudden there was some information stored on some storages that was becoming very popular in a zone that was far from where the storage is. If your system and your management level or monitoring level was able to detect that, you could on the fly activate storage on the infrastructure closer to this hotspot. That storage will be aligned with the existing data, and once it's operational, right, you will be able to answer information locally. This is actually like content delivery network works. So all of a sudden, doing a CDN in Zeno, it's trivial, which is kind of interesting. And computation. So suppose that here a car wants to get some navigational aid. And so he said, okay, look, I want to get this kind of a navigational aid. And the closest queryable that actually satisfies that query is this one. It will be triggered, and eventually the information will be sent back. It moves around, right? Where in mobility case, in this case, this other queryable will be triggered. So once again, built-in support for mobility and load balancing, because all of a sudden, if I have multiple computation distributed, right, there will be naturally load balancing. You do not have to do anything. It's just a consequence of how Zeno works. Okay, let's move into the programming API. As I was mentioned before, we have two implementations of the Zeno protocol. One written in Rust, okay, and one written in C. So first of all, let me explain why. So when we decided to rewrite Zeno in Rust 3 years ago, one of the reasons why we decided to go for Rust, besides the fact that it's a pretty advanced programming language, I think it's the future of system programming, memory safety, efficiency, despite all of those nice features that everyone is aware of, it was for another reason. That the goal of Rust, right, especially with embedded working group, was to be able to run Rust bare metal on microcontroller. And that's still our dream, okay? Because if you think about Rust, if you had Rust with something like Embassy, which is possible today, Embassy is an asynchronous framework for those of you that are not familiar with it, and a decent portion of the standard library, I mean, all of a sudden, it's like having an operating system. Okay, you don't need much else. Okay, and that's super powerful because that means that you have a safe programming language with minimal overhead running on a microcontroller. It's like, it's our dream. So you will notice that portion of our Rust code base are already NoSTD compliant. And the plan is eventually, we already have a kind of tiny version of that running in our labs, not public available. But the goal is eventually to be able to run, and obviously as the microcontroller ecosystem around Rust also mature, is to be able to run Zeno bare metal on microcontrollers. But in any case, short term, right, we also needed to address the microcontroller world, which is still mainly driven by C. And this is why we decided also to do a C implementation of Zeno. The advantage also of having two implementation is that whenever we do a protocol change, we always implement on both, and that makes sure, right, that we can test interoperability, and the fact that as there are two different teams working on Zeno Rust versus Zeno Pico, right, that our internal the specification, it's really implementable. So I think it's also a good health check that we have two independent implementations that interoperate and work together quite well. Now, the other nice things, as we'll see, is that the C and C++ API are Zeno API. They are not specific either to the Zeno Rust or the Zeno Pico. So you can write application using the Zeno C API, as we will see, and then target either the Rust runtime or the Zeno Pico runtime. I will show that with actual code in a moment. Okay, I will show you how to do that. It's just you decide that a compile time through your make file, your CMake or your make file. We'll see that. Okay, so I think this is what I wanted to cover. So let's go to the Rust API. So in Rust, we provide both support for the synchronous and asynchronous programming model. By the way, I was traveling up to yesterday late, so I haven't checked if we have merged it. But if we haven't, we are about to merge the port to Tokyo. So the example that you will see in this webinar are still based on async STD, because I decided to do all the example and make sure that they compile with the latest release that is still based on async STD. But we had chosen async STD for performance reason a few years ago. I think the performance gap between async and Tokyo has closed up. They are very close now. In many cases, the difference is insignificant. In some cases, async has an advantage. In some other cases, Tokyo has a little advantage. But the ecosystem, it's much richer in Tokyo. And so we decided to move on Tokyo. And again, the PR will be merged quite soon. But once again, this example will be in async, and I will change the example to Tokyo as soon as we have that on the merge in the main repository. Okay, so besides providing sync and async API, we use builders everywhere to ensure evolvability, and there is this resolve that you have to use to craft your request that eventually is executed. So how do you choose which API you want to use? Is just by doing the proper import and pulling in the right prelude. So for instance, if you do a use Zeno prelude sync star, that is the synchronous prelude. And if you use Zeno prelude r pound, and again, that's an escape, right? Because async is a reserved word. Async, that pulls in the asynchronous API. And this is how you would open a session, okay? In both cases. Again, the rest is used to resolve the builder. And then the specific await is just because it is an asynchronous operation in the second case. How about C++? Well, in C++, we leverage modern C++ as much as possible. We try to make the API ergonomic for a C++ programmer, and that's a philosophy that we have for all programming languages. I mean, we think that if you are a C++, a Rust, a Python, a Kotlin programmer, you expect certain style, and there are certain idioms that are usually common in API for those languages. And so we provide the same semantics, but in a way that is as ergonomic as possible to a programmer in a given programming languages. The other decision that we took, and there were lots of debates on this, well, actually not exactly on exception, because I think everyone was agreeing that we shouldn't use exception, and we are using variants to propagate error. But you will see that there are two ways of propagating error, and that has also to do with avoiding memory allocation in some cases, right? We either return variants or we allow you to pass to pre-allocate a return value, depending on what makes sense where, okay? But in general, the API in C++ was designed to avoid the use of exception as much as possible, okay? Or at least make sure that you could avoid using exceptions. So how do you open a session in C++? Well, the open is one example of a function that returns a variant. So perhaps the first things that you would do as a C++ programmer, right, it would be to use the standard get to get a session out of the variant that the open returns. And notice that the config has a move semantics that allows nicely to express the concept of move that we also have in Rust. Now, what is the problem with this code? The problem with this code is that if the open failed and we returned you an error, then there is no session in the variant, and you're going to get, the get is going to raise an exception such as there isn't session. It's not going to actually provide you the right error. And so the right way, or the most schematic way in Zeno to opening a session is to use the Zeno expect, okay? So you would do Zeno expect, you expect a session, right? And the expect, if doesn't find the session, then unwraps the proper error, okay? So that's really how you want to deal in Zeno with variant. Whenever an API returns a variant, please use a Zeno expect, okay? Because that's the right way of dealing with it. Or do error chaining, whatever, but don't use get. And I think that the motivation is clear. Then how do you publish data? Well, publishing data, again, it's trivial in Zeno. You don't need to create a publisher. Once you have a session, you can do put your key expression and a value. And if the value is a primitive type, you just put the value, like here, a string, okay? And this is true for Rust, this is true for C++, this is true for C, this is true for Python, and so on and so forth. So super easy, okay? How do you produce data with the publisher? Well, as I mentioned before, publisher are just an optimization. So in this case, you are declaring a publisher, right? And we are putting a frame. In this case, we don't, as we are using a publisher and the publisher is associated with a key expression, we don't need, well, we cannot, we don't need, and we cannot, should not pass a key expression, okay? C++, the code is quite similar, okay? Again, you see the use of the expect, and then declare and the put. So here you have a list of the encoding supported by Zeno. We're adding a few more because we will add protobuf, CDR, and a few other also as first class. But then this is an extensible system, and there are some other small changes that we are doing as part of version 1.0. So here you see how you can write, or some example of writing primitive types, or the fact that you can write a vector as such, right? You don't need to do anything special. So a vector is also understood primitively, a vector of bytes by Zeno. You can write in some API, okay? So this is not universally available on all API, and this is something I want to clarify. Why? Because we don't want to make sure, well, we don't want to force you and us to have the dependency on a JSON library in C or C++. So JSON, you have some facility in the Rust, in Python, in Kotlin, but those built-in facility are not there, for instance, in C++, okay? Because if you were in C++, as those API also target embedded, all of a sudden we might pull in some dependencies, which doesn't make sense. Those should be optional. And as of today, they are optional in the sense they are not there, okay? Maybe in a few months, they will be available as a compile time selection, but as of today, they are not there. How do you set the encoding in C++? So in C++, for any operation that accept options, right, you have an option type. So in this case, it's put options, and you would set the encoding, for instance, in this case, and then just pass it as part of the put operation. So let's see how do we subscribe. So you declare a subscriber, you pass a string key expression, and does the subscription. The consequence is that any resource whose key matches this key expression will be received by you, okay? In C++, the code is fairly similar. You see again the expect, but there is a warning. This applies to C++, applies to Python, and so on and so forth. And I think the big difference between C++ and Rust is that Rust would give you a warning. In C++, you don't necessarily get a warning. So what is the point? Here, you see that I'm actually assigning the subscriber to a local variable, right? If I don't do that, the subscriber will be destroyed immediately, and that will cancel my subscription, okay? So keep this in mind, because if you do declare a subscriber, you pass a callback, as soon as your subscriber gets out of scope, the subscription is automatically closed, okay? So that's something you want to keep in mind. You can also have subscriber R streams, and that's in the Rust API. This option will be coming soon also on the C++ API. In fact, I should be there as the next release. And then specifically in Rust, obviously, you can use stream to do some higher order programming. Okay, QoS. There are a bunch of QoS supported by Zeno, right? You can control the reliability. The default is best effort, but you can control reliability. And you can control the congestion control. Congestion control is either drop or block. Drop congestion control means that as soon as we detect congestion, we start dropping samples, okay? Even if you're assuming reliable communication. Why so? Because that's what you are asking us. And the block will block the producer of data whenever we detect congestion. Okay. Why do we provide these two models? Well, because the dropping allows you not to accumulate stale data. Because if the network gets congested, right, and if you're sending data for which the latest value is the most important, you really want to make sure that you don't accumulate stale data. Okay, that's very common in communication. The telecommunication network works exactly the same way. But if you're sending, important data that should never be lost, right? Then in that case, you have no other choice but block. And again, I mean, this has to do with some result in distributed computing reliability. You cannot guarantee in the absence of infinite amount of memory reliability and progress. You have to choose between one of the two, and that's actually what this gives you as a choice, right? You cannot assume that you have infinite amount of memory. At some point, our buffer will fill. In that case, what do? Do you block? Do you drop? And that's how you control that choice. You can also control the priority of the data that you're writing. There are 7 levels of priority from background up to real time, the default being data. And that's, again, pretty straightforward. You do it with a builder in Rust and with the option in C++, as we are seeing here, right? So in here, you have a publisher option, and then you can use Fluid API to set, for instance, the encoding, the session control, and the priority, and then write with the proper options. Okay. Well, building in Rust is straightforward, right? You create your cargo file, you add a Zenoh dependency, the async std dependency, done. I mean, pretty straightforward. So let's look at C++. In C++, I mean, this example here will use Zenoh C API, which pulls in the Zenoh Rust dependency, okay, for your C++ application. So you have three potential way of using Zenoh in a CMake. You can add explicitly the path to the include in the library. You can use the find, or you can use the fetch content. And when you are developing, I mean, this, especially if you are developing on the master, that's actually another good way of using it. That's typically how we use it internally. Okay, so that's what I'm showing here. And then you add the executable, and you link to, in this case, the Zenoh C library. Okay. And if you wanted to use ZenoPico, well, you just provide the ZenoPico repository. You change the dependency. Oh, sorry, there is a double private here. Let me. That is a mistake. And that does the trick. Okay, so now getting to how you deal with user custom serialization. We're always asked, how can we do to use protobuf or similar technology with Zenoh? So let's take a look at it. So let me go here for a moment. And I mean, we often get asked about protobuf. So what I have here, hopefully my screen is big enough. Maybe I'll assume that it's big enough, okay? Because I'm going to need quite a bit of real estate, so I don't necessarily want to increase the font. So you see here, there is a protobuf message defined called image, which has a format, a width, a height, and an image. So that's the content. It's represented as bytes. Then if we look at the CMake, well, you are not forced to use 20 as a standard. You can use 17. But then it includes protobuf. And by the way, on macOS, actually, you have to explicitly add this dependency on this library that is used by protobuf. Otherwise, you will get link error, okay? And by the way, this example, I will show you, they're already available on our GitHub. Because if you're trying to build protobuf with CMake, at least on macOS, you get sometimes in trouble, again, with the dependency of this abstract library. And you will see lots of people struggling with this on the internet, but this is the exact set of dependency that you need in order to build successfully. And again, as I was mentioning, that we are making this available on the internet, let me actually show you where. So if you go on GitHub at ZettaScale Labs, you will see that there is now a repository called webinar. And in this repository, you have all the examples, including the config that I will be going through. And yeah. Okay. So this is the CMake file. In this case, notice that we are using Zenoh. And so let's look now at the code. So in here, okay, I'm opening a session. So this is the code that is opening the session, nothing new. Declaring a publisher. And again, the reason why I'm declaring a publisher is because in this example, I wanted you to see publication out of a publisher or out of a session. So you will see that that's done this way. And then in this case, there is, well, this is code that has nothing to do with Zeno per se, but essentially, this application fetches images, okay, and then serialize them as this type here and publish them, okay? So what this is doing is taking the light blue, the light version of the Zeno logo and the regular version of the Zeno logo, creating images out of those, okay? And by the way, in this case, actually, what you will notice is that I have these two extern here. So this code isn't doing any actual conversion, but the images are already made into ASCII. And then, we'll go to the next level. We'll create a queryable that actually converts arbitrary images to ASCII, and we'll do that with Zeno. So, but if we go back here to the publisher, so is essentially, creating. This is our image type, right? And then, well, it starts a loop. It sets some, arbitrary encoding, whatever. And what it does, it then publish the payload, okay? And if you look the payload, it's created how? Well, it's simply created by serializing the image, okay? And this is the serialized to string method that is generated by protobuf. So once again, this is the type generated by protobuf, and then honestly, serializing it into a string, it's quite trivial, and you can write the string natively, okay? So that's quite straightforward. And here you see that either we put on the session or put on the subscriber. So let's look at the subscriber, and then we'll run the code. So the subscriber, it's quite straightforward, because we declare a session, we declare a subscriber, and here we have the render image. Render image, what does? Receive a sample, and then it parses the image, okay? And that's it, okay? So it's very straightforward. And you see I've just defined the operator, the streaming operator for the image to print it out, to make it more convenient. So once again, I mean, it's pretty straightforward to use Zeno with your favorite serialization mechanism, and that's in C++. So let's start here our subscriber. Let's start here our publisher. And if I do 1, obviously I get the light. I do 2, 1, 2, and 0. Okay. Now, before moving to Rust, suppose actually that I wanted this cute logo to be stored somewhere. How would I do? Well, not so hard, right? Because what I would do, I would start, I mean, as far as I have some infrastructure node like a router, activating some storages that would do the job. And so what I have here, and by the way, the configuration is also available on the repository. I've started a router. If we look at the configuration, I'll scroll down because that's the relevant part, that defines 2 in-memory storage. One keeping data for demo/star and one for zeta/star. Now, if I query my routers, and how do I query the router? Well, I can use REST. By the way, I have also activated the REST plugin. Okay, so I can use REST to interrogate Zeno. So HTTP localhost 80 slash, if I do, demo slash, let's say, ***, well, there is nothing, okay? And now, if on the other hand, I go back to my C Lion and I start the publisher, I start here the subscribe. Oh, the subscriber is still there. So suppose I publish the light logo and I go back and I make a query. Hey, we got something, and that's the light logo. Obviously, this is serialized, so it doesn't show properly. And what if I publish now the dark logo? If I query again, and in fact, actually, let's change the query. So this is the name of the resource is, yeah, let's use demo/bulletin/star. But it doesn't really matter because but just for a kick. Now I'm getting also the dark, okay? So that's quite neat. Okay, so let's keep this one running and let's move for a moment on Rust. So something else that I've committed is a bunch of examples that show, well, before getting to that show basic publishing and subscribing, and then also how to publicate images, because that's something that we've been asked for quite some times. So if we look at the put, here we have an example that puts data in various primitive, supporting various primitive formats. So let's just run it and notice that these are all resources called Zeta webinar something. So if I do target, oh, I'm already here. So if I do put, sorry, before doing this, I want to make another query. I believe I closed my window. So let's do here. Yeah. So if we do Zeta/**, there is nothing. Okay. So now let's do a put. The put is completed. So, here is the data that we just wrote, okay? So obviously, I'm running a router here, right? But the storage could be on the other side of the world. I have no, when I could do the same query from the command line and I would get the same information, right? So that's the interesting things about Zeno. But let's go now through a little bit more advanced example before wrapping up. So that illustrates the use of querybles, to do some interesting computation. So in this case, we have a publisher, and this publisher actually converts arbitrary images and publishes them. Okay. So what I could do in this case, for instance, I could do pub. This is under that, I believe, webinar 2024. And then Rust. Yeah, that's good. And I think this subscriber is already running, but let me start it again just to, yeah. So here we start. Let me start the subscriber. No, I don't have subscriber. I should start the C++ subscriber then. Let me start. Or never mind. Actually, if we do this, okay, now on theory, if I do a query, actually, let me close this window so we'll always find that one. So if you do a query on the demo, there is now also, no, it's not there. Okay, never mind. Maybe I provided the wrong path. So let's do with the queryable. So what I want to do here, I want to show the code of this queryable. So in this case, I have So let's go up to the main. Again, I'm opening a session, declare a queryable that is a transcoder, image to ASCII. And then what it does, okay, whenever it receives a query, because you see here I have a stream of query. So this is the while loop in which I'm receiving query. Each time I receive a query, right, I get the value of the query, and if it's actually a sample, then what I do, I take the payload of the query, and notice that this continuous allows me to have a contiguous representation of the payload, okay? And this is the image name. I create a path out of this image name, and then I convert the image to an ASCII image, and I reply with this, okay? And the way in which I can issue the query is by obviously create a session, and then with a session, I can just issue a get in which I use the key of the queryable. And notice that I'm passing an attachment. I'm attaching a value, and the value is actually the name of the image that I want to transform. Okay, so let's start here the queryable, and the queryable asks for a path where the images are. I mean, I could have sent the image through Zeno, but I didn't just bother to do that. Okay. So if we do target debug, and here we want to do ASCII image get a queryable query, and let's say Zeno.png. Here we go. Okay. And if I do open on this side, this is the actual image that has been transformed. Okay. So if I do the same for ZettaScale, oh, operator error. There we go. Okay. And obviously, if I look in images, ZettaScale, that was the image that was there. And by the way, all this code is available on the GitHub repository that I was pointing out before. So GitHub, ZettaScale Labs. I think there has been a burst of commit. Here we go. If you look under webinar, all of the code is available here. So we were looking under, this example here now. Okay, so you have all the code here. And as I was mentioning, the config used for the router is here. Okay, and we will go more in details of some advanced configuration next webinar. So, well, 1 hour isn't enough, right? We could remain here to talk for hours and hours, but I'm already 6 minutes past the hour, so sorry for overrunning a little bit, but hopefully this was useful and interesting. So wrapping up, so we are here to try to bring you and provide you the best communication technology, not just to move that around, but again, to query data from around the network and distribute computations. The community is growing very quickly. So obviously, thank you for your interest in Zeno, and I mean, thank you for your support, for all the good words that we get on Discord. So all of that is very motivating for us. And again, keep. I would say, let's keep going, let's keep moving. We're always curious to hear about your feedback, what you would like to see in the product. Please, if you haven't, don't forget to star our repository, because that's always positive. Help us spreading the word, and I look forward to seeing you next week. Next week, I will have some other team member. I think we'll try to go into perhaps some of the some other API corners, but perhaps some advanced configuration. Okay, because I think those are the areas where there is a little bit less configuration, and where you can pull some interesting hat trick if you know the inside story. Okay. At this point, let me check if there are any questions. But if there were questions asked, in any case, let me stop sharing my screen real quick. So I'm going through the questions. Okay. So if there are no questions, you still have time to ask questions. I mean, I can stick around a little bit more. So thank you. Let me actually paste the link to the repo for convenience, so you guys will get it there. And I just spotted that for some reason the CMake file wasn't committed. So I'm going to commit the CMake file for the C++ immediately. Otherwise, you guys won't be able to build. And the slides. Okay, so question, is there any progress of Zeno Pico over LoRa? So we did actually some POC with Central Supelec here in the Paris office last year. And again, it was about LoRa, not LoRa 1, right? There is a difference. I don't know if for everyone this is clear, but in LoRa, there is not MAC access control. You have to do it your own MAC access control. But that's kind of interesting. That's where we did some experiment. We never committed that because it was rough code. And then the problem is that the partner we were working with, I mean, they had some issues with their LoRa network. They're not using LoRa anymore. Long story short, concerning your question, do you really mean LoRa or do you mean LoRa 1? Could you please clarify? Okay, it's LoRa. Okay, sounds good. Yeah, so we have done some experiments, but no, that's not finalized. If you're interested, I mean, reach us out on Discord. We can, I mean, if you want to contribute that, we can clearly point you out on how to make that happen, okay? And in terms of things that we're working on, we're working on a protocol plugin for Canvas. So that should be coming up pretty soon. Okay, are there any other questions? I'll wait another few seconds. So if not, I will thank all of you. And I'll see you guys next week. Ciao. Thank you again for being online.